Good morning, sir.
Morning, guys. Okay. Okay. I think first few minutes, I'm going to briefly explain you about the scope of Unit 12. We're going to discuss briefly on that, and then we'll focus on the test 3, and overall idea of how these questions that I've given in test 3 need to be written, and briefly connecting to how you have written them. Any major issues in your answer writing related to that. Okay, we are going to focus on those two aspects today. It won't be too long, so about an hour that we are going to take. Starting with the Unit 12 part, because in the last session we finished talking about the Unit 11 part, correct? So in the Unit 12, definitely this is focusing on specific application aspects of anthropology. Specific application aspects of anthropology, right? So we build understanding on various basic components like genetic components and other components like epidemiology, ecological component related to anthropology in various units so far, correct? So 12th unit focuses on the specific uses, okay? Like they've specified what areas that we have to focus on. Like first they say anthropology of sports. In sports, how is anthropology used? Second, they talked about nutritional anthropology, how anthropology is used related to the nutritional aspects. Similarly, anthropology in designing defense and other equipments, and forensic anthropology. So a very important area where bit of explanation is required for forensic anthropology. For rest of it, like sports, nutrition, it is mostly knowing what to write, what should be discussed under each of this. But for the forensic anthropology, little bit of more basic understanding is needed related to our physiological differences between different genders. So that I'm going to deal in next class. So today we're going to briefly talk about how anthropology is useful in sports and nutritional component. Okay, we are going to focus on those, and there are a few other topics that we are going to continue after that with the in the methods and principles of body reconstruction. So mostly forensics. So we'll discuss about how timing is identified of the death, and how do you know what gender it is after several long years of death. So, and age, how do we predict age? So like the differences, part of them we discussed in unit 10 related to growth. Part of them I have to explain you. Okay, plus other topics like DNA technology, which we briefly already discussed, eugenics, some short note focused components are there, right? So let's begin how anthropology is useful to us. In what sense anthropology is useful to us? Okay, so I'm going to share this slide with you. So this is technically not too complex, but we have to develop the idea here with respect to that. So I'd like to begin with the simple observation here. Okay, so if you see in Manhattan, developers plan ever taller residential towers. Okay, so how long it would actually take some of the world's greatest athletes to sprint there? If you talk about, this is at Central Park Tower, okay, in USA, in Manhattan. So people are actually focusing on building these type of towers. This is a simple idea. So if you actually take different people may take different amount of time to get there. Okay, world's greatest athletes, okay, either to sprint, serve, or swim. Okay, this is going to be about 1,550 feet. It's like Highlanders living in a, it's like people living on the earth, but they're taken to the highland regions. So they require certain adaptations, as you see here. Usain Bolt could run the length of this building in 45 seconds. Okay, he can sprint in within about 45 seconds. Okay, whereas Serena Williams, I think these names would soon change, right, are already changing. So she can actually put a ball which can reach here within 2.3 seconds. Okay, whereas Michael Phelps, okay, he could swim the butterfly across the length within 3.5 minutes. So what do you notice here? These people have some sort of inherent capacity to reach certain height. So where is the difference coming from? Is there something to do with their body type? Is there something to do with their body dynamics, or something to do with the training that they have gone through? Okay, so definitely, I think in us, some of us have that ability to do something better than the others. Where is that coming from? Can we actually address this or understand more about this using anthropological tools? Okay, so basically, I'm focusing here on the sports. I'm going to explain you a few terms related to how anthropology used here. Okay, anthropology of sports. Anthropology helps us understand about our biology, like genetics that we component we talked about, biochemical, immunological components we discussed about. Like anthropology gives us a connection to human biological component, especially talking about physical anthropology part. And especially we have to use the technology or the process called anthropometry, which I briefly explained to you with respect to somatotyping. What is anthropometry? Metry means measuring something. Measuring what? Measuring different aspects of our body. So anthropometry is a method where we measure certain aspects of our body, maybe length, maybe fat, something that is quantifiable, something that is quantifiable. So this is refers to anthropometry. And there is a specific application of such measurements in the field of sports. Okay, we call it kinanthropometry. What is kinanthropometry? Kinanthropometry deals with, this is a specialized science which links human structure and function. So what do you do? There's a particular individual has certain function, certain structure, certain shape, certain amount of muscles, as we learned in the growth part. So we are trying to link that component. How is the structure of this person built? Functionally, how is it related? Can he perform better in certain sports than the other? Okay, so how do you know that? By measuring, by identifying certain elements of his body and by taking measurements of those parts. What are those features? Maybe height, how tall they are, what is their weight, what is the body composition, like endomorphic, ectomorphic, mesomorphic that we talked about. Are they made up of more muscle, more fat? If fat, where exactly fat is present? That analysis can be done on the body. So with the help of this measurements on height, weight, body composition, shape of the body, proportionality of how muscle and fat is distributed around the body, one can actually try to utilize this in the field of sports. Okay, that field is called kinanthropometry. So kinanthropometry is a specific type of anthropometry. Anthropometry is a in general sense, taking measurements of anthropos, human bodies. So various features of the human bodies, those that can be quantified, come under anthropometry, right? So we talked about anthropometry, anthroposcopy, photoscopy in somatotyping, right? So here we're specifically talking about how a specific category of anthropometry called kin anthropometry helps us. Okay, so the first part that in the applications of anthropology is taking such measures using anthropometry in various fields. Let's see how this is useful in sports. I'm going to give you a bit of definitions and some observations along with statistics. Okay, so as I was already telling you, what is kinanthropometry? Kinanthropometry, the science of measurements of body and those parts which are related to kin means kinetics, movements, and kinematics. So this is related to how body movements happen and how body movements are defined by certain features of the body. So this field is called kinanthropometry. So if you want to write a standard definition for this, given by Ross et al. In 1978. So it is application of body measurements to the study of human size, shape, proportion, composition, even maturation. Okay, and gross function so as to help understand the human movement in relationship to lots of things. Could be growth, could be exercise, performance, and the type of nutrition that they are on. So basic idea is measurements that we take and relating that to the various aspects of our dynamics like growth, exercise, performance in sports, nutrition. That is a field of kinanthropometry. I'll provide these definitions, okay, in the handout that I'm going to give you, but understand this basic picture. Get this basic picture and understand the term kinanthropometry. Are you able to follow this? So taking different measurements of the body and trying to understand the movements that this body can make and what is its relevance to various aspects relevant to us, like growth, exercise, sports, diet. So those things that we focus on in anthropometry. Yes.
It is a subset of anthropometry, like related to kinetics, the moment.
Exactly. It's a subset of anthropometry with a specific application in one particular field. Okay. Even actually these, I remember in the university where I was doing my PhD, there was a department dedicated to what is called kinesiology. So where I think they were studying the science behind body's flexibility, body's movements. So basically a different dimension that we are looking into, so that we are adding science to the parts of sports. Otherwise, just choosing people, training people sometimes may not help because competition has become too much. Olympics, look at Olympics. People are actually extremely competent, but there is a limit of how much we can train them. If they have already some inherent genetic components or they have some body features which make them better suitable for the sport, so even filtering can be done better. And then training, because people can get training anywhere nowadays. I think people go to Australia, people go to America, Europe for training. So training component, we are optimizing it. But if they have inherent quality of doing it better, so they may perform better. So we are adding not just the concept of training here, but their body dimensions. So we're bringing this science of anthropology or science of anthropometry for winning those games, for performing well in those games. Okay. So this is one application of that. Right. So I provided a brief description on these things. Okay, here how kinanthropometry is used specifically for this. Let's have a look at that. And kinanthropometric investigations are important in establishing the prerequisite characteristics of athletes. As I was telling you, for a given sport, there must be some prerequisites. I'm going to give examples of them. For swimmers, what type of body composition is needed as per the science. So we understand that there are some prerequisites of athletes, so that when they get trained, they can perform their best, or they can show the maximum performance. So we are trying to relate those requirements to the body types through anthropometric analysis. So what does it provide? This anthropometric analysis provides us quantitative view. It provides us quantitative view. It provides us quantitative view on human structure, how they are built, how they can perform. So what is the use of kinanthropometry? Make these points, okay? Because this is part of my way of explanation to this. Although in the handout I have a description, but you develop the idea, write down the idea that you are developing, which will make it easy for you to follow the handout. So we defined what is kinanthropometry, and we are learning, because sometimes it is, we know that it's a connection between body and performance. How much can you write if you are given short note on this? So you have to have enough points and ideas. Because the principle is simple. I can explain it in 3-4 lines. You might be experiencing that while answering questions, but you need to write more to satisfy the space requirements. So what elements you have to write, how you have to describe. So these are the ideas that you receive here. So it provides what this anthropometry provides us quantitative interface between structure function. So correlation between the structure, how well is designed, how well they can perform with that design. So it gives us a quantitative interface between them, a quantitative connection between them. Okay. So next, as we discussed about what do you measure then? What aspects of the body do you measure then? I was already briefly talking to you about that. The techniques actually help us making measurements of height, weight, diameter, circumferences, skin folds. This is exactly what we learned in the somatotyping. I've even shown you the different aspects of the body can be measured, like triceps, for example, calf, like chest area. So circumferences that we can measure. So fat in certain regions of the body we can measure. Okay, those type of measurements, which are nothing but anthropometry. So those measurements provide us the knowledge about those quantities of those features. So structure, we are quantifying the various structural elements here. So how this is done? The next question, if you ask how this is done, by taking measurements of some key elements of human body, which are relevant to the functional aspect. And this is becoming more and more common these days. As I was telling you, given there is high amount of competition to win between countries, okay, so this is definitely gaining popularity and being used in identifying the potential sportsmen for a particular field. Okay, so this is being used. The science of this science of anthropometry is being used in selecting specific potential people who could perform better. So basically, we are quantifying their characteristics or physical characteristics related to particular field and using it as a method of selection. Okay. Right. So athletes in a particular sport must possess such specific characteristics which are advantageous to them during the game. So for their performance, to utilize those features, to give examples of swimmers, for example, or in different sports like basketball, for example. So what type of body build is necessary for them? Okay, so we can actually have those specific characters being defined. Either they naturally have it. In addition to that, what aspect of it, what food they have to take, and how do you have to train? What type of specific training is required? So much goes into this part. Okay, so physical characteristics such as body composition, size, type, structure are considered to be the key factors in enhancing their performance here. So body composition, like fat content, muscle content, size of the body, whether they're short or they're tall. Okay, type of build, endomorphic, ectomorphic, mesomorphic, like that build, and overall structure. So these components we mostly focus on here. Okay, so these factors are definite predictions of the degree of efficiency based on this composition. For example, if they have more fat composition, okay, or there's a good proportion of muscle and fat. So people who could actually run and require extra amount of energy in the process, little bit of fat is needed, because for that movement you require enough energy to support the activity of movement, correct? But how much can you eat? You cannot eat so much, right? So what do? You only have so much of reserve of food. But let's say you have to run a marathon. Where do you have the extra amount of food in your body? There must be some amount of fat present in your body. So when you are running something like that, you are converting fat into energy source. Extremely thin or lean people may not able to satisfy. You need a little bit of fat on that. So that people with enough muscle to help in the movement, plus a little bit of fat, which can be converted into energy when they are starving. Otherwise, the amount of food they have eaten, they might have already utilized it by the time they ran first 5 kilometers, 10 kilometers. But they have to run another 12 kilometers, 13 kilometers of half marathon and further on. Where do you get energy from? You're not allowed to sit and eat in between, right? And if you do it, you won't be able to digest, because your digestive system also requires enough amount of energy. So here a little bit of extra fat is useful to them. So connecting that, so like what factors would provide or help us to predict the exact efficiency or specific efficiency of that sports person, comes from these type of measurements. And sports trainers can direct young athletes in the sports that best suited. So they can filter them, they can select them. Even in the process of selection, they say you are probably better fit to this game. I know, like sometimes if you see someone like really tall person, you may think that is good for basketball, for example, right? But we're focusing much more than that. Like different body elements, their proportionality, their height, their weight. Okay, so these components will be used for initially itself for selection, then for training. So Olympic studies, this is old study, 1960s and 1980s. Some studies have done where they indicated that successful sports performance is often hindered by lack of appropriate physique. You can only do so much by training. If their body doesn't support, of course, you can train a person to be best, but the same training has been given to another person whose body is better suited to that game. So who would actually outperform? The one who is both A and B are trained equally well. But one has a body type which has an advantage for him to perform well, perform better. Then definitely this person A with a better body build with same training would have advantage over the other person B who has excellent training but not a body that supports that particular type of performance. So they said definitely, I think initial selection process would be of great help. So morphological optimization is associated with the success in different sports. So then you focus on optimizing the structure. But can you actually increase the height of a person with training? You cannot, right? There's a genetic component that puts limit on us. Parents' genetic elements would define what height you are going to achieve along with the environment. Environment component here is training. So what do you do here? So it's better to choose a person who has certain features, and top of it provide training so that you can get the best out of that person. So initial anthropometric use is in selection and in defining what type of training is required. Example, like what do you notice with respect to what type of body type is suitable? Like for example, studies show that athletes who are sprint runners, so they need more muscle. People who have more muscle, who are trained to gain more muscle, they're good at sprinters. They're good as sprinters. Marathon runners, bit smaller and leaner. Why? Various aspects of ecological anthropology that we talked about. If they're small, okay, so the smaller people who are tend to be smaller. So we notice the various aspects of the heat loss, energy conservation is different in people who are tend to be smaller and leaner. Okay, they have to carry less body weight, less requirements of energy spend. So usually smaller and leaner with bit of fat, okay, are useful for marathon. And the throwers, they need to be more taller and heavier because they have to carry enough weight and push enough weight. Okay, So these people have to be taller and heavier. We notice that in somatotyping also, I have placed them into different categories. Okay, so people with the body build of tall and and heavier bodies are suitable for games which requires enough strength to throw things. Jumpers, long jumpers, for example, they need long legs, short trunk, broader feet for better balance. So I'm giving you examples of features which are suitable for specific type of sports as per the studies done. This is 1996 study. Norton et al. Had published this work where they have discussed about various features of sports people. Some need to be muscular, some need to be smaller and leaner, some need to be tall and heavier, some need to be have long legs, short trunk, and broader feet. So these same features may not be suitable for marathon runners. So selecting them and guiding them in the right direction would result in the better medals, more medals, because we always fight with China, right? We always have the political comparison there. Similarly, gymnasts, people who are more shorter have better outcome. Chinese, Koreans, Japanese are doing better in gymnasts as gymnasts, correct? In Olympics. Why? Their body build is better suited. So like that, we are able to see those connections between body type and their performance or potential performance in a given sport. Okay, these are some examples. Make a note of them. What type of body is suitable to what type of sport? Yes.
So this includes few characters which are, as you said, genetic, like long legs, height, and
Correct.
but there are a few other which can be developed over time or by training also, like the weight of a person, the muscle, and other things. So in selection, we have to keep that variation, or like just that.
In selection, what do you do? Basically, you begin with the what inherent genetic components are suitable, are required for that particular game. Okay, so you start with that because training can provide those aspects. With training, they can build muscle in certain part. With training, they can put on more weight here. Okay, so those things, the shaping or fine tuning can be done with training. But what cannot be done is to go over the genetic potential. So what do? You cannot increase their height. So during the selection process for a particular sport, let's say you are actually selecting people for like long jumpers, for example, what do? You choose whether they have long legs, the body proportion you look at. Okay, then provide the training. So initially, because we cannot change the genetic components, so you choose those people who have those features with training that they can perform better, right? In various sports, that is what they normally do. So initial selection should be based on what genetic potential they have, plus training afterwards. So together we can expect the optimal performance. Otherwise, what happens? You can randomly choose people because they have passion. Then what happens? Passion is definitely an important thing, but if the body is not supporting, what they can do, how much they can perform. If another person who has a great genetic potential, good same amount of training can outperform you. So we are actually trying to not take any risk at all here. Like basically, you are trying to do the best selection. Use science to select people, train them best, expect more medals. So basically, using anthropology for attaining that. So I would like to give you this success behind some sportsmen. So you recognize this person, right? Who won several gold medals? Michael Phelps, right? So what made them to win or outperform many other people? In most of the sports, the minimum level of fat is required for better performance. As I was telling you, in some games we need minimum fat. Majority of the sports we need minimum fat to provide that energy requirement. Okay, and increased levels may obstruct sportsmen from reaching their full potential. Just enough. Too much of fat may not help because then it actually affect their momentum. Correct. So you have to have just enough fat. The sports which require body projection, such as jumping movements against the gravity, excessive fat and body weight hinder the sports performance. Right. So sometimes in the way you actually move, it is more aerodynamic movement. So the body projection, especially when you are jumping, and those movements have to go against the gravity. So having too much of fat may not help you because then body weight hinder your performance. You can only do so much. Your body is not supporting. Physics is not supporting your body performance, right? So, like for example, in long distance swimming, like what you notice with the Michael Phelps, for example, and also like in water polo, the moderate level of fat is considered as an asset. So why? Because this helps in additional buoyancy. Buoyancy is that up thrust we feel, up thrust, the pushing thrust that we normally feel, or a force that is acting against this because you fall in water, you're trying to swim. That little amount of fat is required to push you up. Okay, so such body types, are able to perform better. That is what you notice with Michael Phelps as well. His body is designed in such a way that a little amount of fat helps him to do wonders in water as a swimmer. So what are we learning here? Little bit of fat is required, and especially how does fat help? Scientifically, if you notice, it provides that extra buoyancy or uplift that is required for swimmers. Okay, these are specifics because I know how much can you write. You said so far. I think overall theme is genetic nature, genetic potential on top of genetic potential, training, and then performance. How much can you write? So what type of features are relevant to what type of sports we talked about? And we're talking about currently when people are able to succeed so much, it is because of their body build. What is that? We're talking about Michael Phelps and a little bit of fat arrangement. Even science goes much beyond it. What part of the body, what amount of fat is required? They're even able to quantify to that level now. Okay. So this is data from the paper from 2012 where they have analyzed the medal winning gymnasts. Okay. So here what they're comparing different features, their height. The one in the red in the middle is height. The one in the blue is their weight. And the one in green is age. Okay. So what are we learning? The medal winning gymnasts, what are their body proportions they're looking at? Okay. So age, most of them are youngsters. They are between 20 to 25 years approximately. People who won the medals, they are of age 20 to 25 approximately. Okay. And what about their height? So you notice that they are actually, so if you notice they are about 60 percentile. So the height is actually suitable enough. And what we are seeing is comparable enough. We are not focusing mostly on the quantities of it, but comparison of it. Look at the most of the winners actually have more or less same height. They more or less have same height. Again, we're talking from almost 1955 to 2010. Same with their weight. Same with their weight. What do you notice? You see a decreasing trend in their weight. Age more or less remained same. Height more or less remained same. Weight actually is coming down. The weight has actually come down. Weight has come down by at least about 30%. Weight had been decreased in a general trend. So what do you notice here? I think age factor is playing the same role. Height factor is playing the same role. And weight loss seems to be helping them to perform better. So this is based on Boston blogs, okay, based on a blog where they talked about how champions' bodies are. Okay, and it is becoming now, we have only narrow scope here. You cannot do more now, much more now. Maybe we can use AI, artificial intelligence, to train people because our brain is only thinking so much. Maybe AI can be used in sports training in future, maybe already being used now, okay, for analysis. But overall body dimensions, as you see, more or less stayed common for almost a half a century now, whereas weight component is optimized. Sorry, height now, weight component is optimized. Okay, so they are actually utilizing this type of science for knowledge related to this, okay, in winning sports like this. Okay, so look at the height of London Olympic finalists, performance of Olympic finalists in various categories of the swimming. Okay, and what are their height and heights in different genders. So look at the height of these people who got selected. 6 to 6.4. All of them are tall. 6 to 6.4. Sometimes 6, 1.5, 6, 6, 1, 6, 2, 6, 4. Okay, all of them are tall. And women, of course, women tend to have compared to the gender differences that we normally notice here. But even there also, like 5'11" we are seeing, 5'7" to 5'11", very narrow range. 5'7", 5'8", 5'9", 5'10", 5'11". So those people got selected, meaning definitely their height has a positive correlation to their performance. You don't have to by heart all these things. Just an idea that women, people who got selected to London Olympics, this is a data that we have related to them. All of them are tall, both men and women are tall, but slight difference between genders. So their height is actually is an advantage here, and they get selected because of that. If you have someone who is 5'6", 5'5", then definitely you wonder the training can do wonders. Okay, but definitely their body proportion is important. Okay, and we are seeing a kind of a trend, a changing trend, a secular trend that we have seen growth is increasing. Minarch, we have seen a trend that age of Minarch is decreasing. Similarly, there is a secular trend in how people are performing. Okay, like we are seeing in the shot put, 1896 and 2016, average height and weight of the people. How is it changed? 1896, the height of these individuals were 180 centimeters. People who are winning the games, 1896 gold medalist, Robert Garrett. Okay, 180 centimeter tall, 63 kg weight. But same thing in the 2016 winner. He's a defending champion, Thomas. 197 centimeters, 180 versus 197, and weight was 141 kgs. Almost double, 141 kgs, 197 centimeters. I was talking to you, people who need to throw things, something like in the shot put, the advantage is the height as well as the weight. So look at the secular trend, how it changed in shot put. So this helps you to reason why are we focusing so much on anthropometry for sports, for performance in sports. There's a clear trend that you notice here. Okay, there may be exceptions, but this is a general idea that we are gaining here. Shot put. So eventually we notice that people who are winning the games are taller and have more weight. Okay, this person versus this person.
Sir, can it be also because of the increase in the knowledge? Not just
Increasing.
because we have more knowledge, we are getting them. But
Yeah,
even
here we are not talking about like what type of knowledge you are saying.
like earlier, we did not have so much studies on about biology or about the physics of things.
So two things here happening. One is knowledge, second one is performance. Observation of how people are performing. You're correlating both. And that is what we are learning here. The knowledge, here we're talking about knowledge of anthropology, knowledge of anthropometry, how this is helping us. And people have done research. If you see a few decades of work, they have done research, they have analyzed this great amount of analysis that had happened on people body type and their performance. So this is what is about knowledge. Knowledge in a systematic manner can help us in outputs like this. So yes, knowledge in various aspects, but putting in an organized manner so we can train people. Those coaches actually have that training, that requirement of understanding for these sportsmen. And you keep seeing it in basketball, for example, 1903, Buffalo Germans player called Henry Fast. His height was 182 centimeter, weight was 74 kgs. In 2016 US Olympic team forward player called Kevin Durant, 206 centimeter, 104 kg weight. 74 kg versus 104 kgs, 182 centimeters versus 206 centimeters. So knowledge plus training had resulted in, or we can clearly see people who are winning, are coming to perform in the games, are definitely more different in terms of their body proportions to how people used to be before. That is because of these aspects that we are learning. Okay, right. This is from McMaster University, a Canadian university, that briefly pointed out the various qualities and requirements these people have. Okay, so the research team in McMaster, a university in Canada, McMaster. So in 2020, this was happened during the 2020 London Olympic Games. They actually focused on what type of science is important for an elite athlete. So what features they should have. Of course, we're not going to get into the details, but you see mind over matter, mental stability, importance of psychological strength, mental stability is important, diet and physical performance. The proper diet, as I was telling you, kinesiology is a field that they focus on this. So kinesiologists, okay, are focusing on explaining There's little margin on victory. Sometimes in a few seconds is enough. That few second performance can come from their body type. Okay, so sometimes even fraction of seconds can make the difference. So athletes who want to achieve their peak performance need to make sure that they're ready to perform in every aspect with proper nutrition and proper hydration. They play an important role. And understanding about their body requirements of nutrition and hydration in relevance to the specific sport. Injury management, we see that in cricket very much. People have shoulder problems, people have knee problems. So they have to understand the vulnerabilities that they have with respect to the given sport. So what do they have to do here? They actually have to be trained and physically do that workout so that their body can perform better. Okay, and then so we have to have like science of sports medicine. So people like physicians, because we normally have the specific physicians who help them having to manage with certain damage that they can cause. Like concussions is very common. If you see the very aggressive sports that you notice, like ice hockey, for example, they hit so hard, right? Concussions are a very common theme there. So what do they have to do? Handling that concussion component, how doctors actually help them to come out of that concussion. So these people with a certain body type can perform better. Plus training, building strength and building muscle. So you look at that, this has become so much of science. Sometimes we may not know that what goes behind these type of components. So much of understanding and knowledge is required and multidisciplinary. We need kinesiologists, we need psychologists, we need cardiologists, we need physicians, okay, and we need people to coordinate and train these type of personalities. So much of science going behind it, and anthropology, anthropometry playing a very, very important role here. Okay, are you getting an idea about how anthropology and what role does anthropology play here with respect to sport? Okay, so this is a brief idea. What I've done, I made a summary on this. This is an overall concept with examples and some statistics I've shown you here. And I'm going to provide you a handout with respect to this for you to read, where I've provided a bit of more explanation on this. Okay, I provided some explanation, like if you see this document that I'm going to give you. So I provided briefly talked about how sports have evolved over a period of time and the importance of body size, body proportions, and physics and nutrition, etc. And I talked briefly about the term kinanthropometry and Bill Ross definition, who introduced this concept, kinanthropometry. Okay, and then we talked about the how importance of kinanthropometry or anthropometry gained attention. So I briefly talked about 1976 Montreal Olympic Games. Okay, so there was a scientific congress that happened, Olympic scientific congress that happened. They focused on this type of kinanthropometry and their understanding. And what are the different factors that are useful here? I talked about various factors that we discussed about genotype, body type, fat components. I briefly discussed about those components here. And how to attain the maximum performance, what type of training that they require here. I briefly explained how kinanthropometry by anthropologists is used to classify humans into different somatotypes and in selecting particular type of sports, plus training that is required. Okay, so like that, studies that are clearly pointing out that the sports and activities and how can they help in performing better. Like I mentioned about throwers, what type of body type they require here. Okay, so those type of components I have put it in the context of sports anthropology. Did you get the idea of what aspects we need to discuss under anthropology of sports, kinanthropometry, and the connection here, and few examples? I think to strengthen your explanation and your discussion, you have to provide examples of how Olympic winners and their body type has changed over a period of time, and how height is actually a very important component in winning certain games. How certain amount of fat is important for something like Michael Phelps. Okay, those examples that you can put. Okay, this is briefly yes.
Sir, does it mean that kinanthropometry over the interest of the athlete? Does it mean that?
Not necessarily. So, as I was telling you in the previous image, multiple factors. The pull towards the game, endurance, body type, training, all of this matters. So when you are choosing, because when we have so much of population, because in the final sport, we only select few bunch of people. Okay, even with the smallest country where we probably have a population of maybe a few lakhs of people, it is sufficient to have people with the interest and the body type to be matched. So we don't have to go against their interest here. We have to match the interest plus people you select based on different levels. So people who have interest, who have a body type, who have that endurance power, you select. So they have to match all of them. It's not like we are choosing over the interest. Okay. So you select out of those selected pre-qualified people who can perform better. Okay, right. Next, I would like to briefly talk to you about the anthropology of nutrition. How anthropology is useful in nutrition component. So what is nutritional anthropology and how this is going to be, if you get a short note, what components would you write of anthropometry in anthropology to the nutritional component? We kind of discussed this in epidemiological anthropology under nutritional deficiency diseases, but our focus is mostly on the measurement part, anthropometric part. Okay, so anthropometry definitely is useful in nutritional assessment, like we talked about it, taking height. As soon as children are born, we check their height, we check their weight, we monitor their height and weight. In a case study also we looked at it, we looked at this, that there is a trend and there is also specific reference points that we have. If a person is fed well, he has to show certain amount of incremental change in their height and weight. Is it possible for us to measure them? Anganwadi workers, what do? They actually check the measurements of people in rural areas, for example, to see if they are actually attaining their expected growth rates. So indirectly, we know what nutrition is given. Whether there is a problem with the nutrition, they can correct that problem. So anthropometry has a great role in nutritional assessment. This has been known for some time. Even in India, Anganwadi workers hold some of those tapes. Even if you go to the clinics of pediatricians, they actually have certain machines to take their height, weight, and head circumference, etc. Why are they doing it? Because it clearly tells about the nutritional aspect of their body, how much of intake is going into them. Or intake is normal, but something to do with their metabolic system. So they can correct for the medical problem. Okay, so undeniably it forms a basis that the fact that the heredity contributes to the growth. We all know that whatever it is, we can only attain so much of height. A hereditary component or genetics plays an important role. Okay, but unless we provide the proper nutrition to that, it is not possible. The genotype is competent enough of its different growth potential in different environment. Here, environment component could be the nutritional component. Okay, so thereby introducing the specialized subdiscipline within the applied physical anthropology called nutritional anthropology. So we are learning the science of anthropometry, understanding the correlation between those measures and the body type, and whether they are attaining the proper required growth or not. If not, look for correction.
Sir,
Yes.
can I ask a question which might not be very relevant to this particular thing?
That's all right. Go ahead. Yeah.
Sir, so there is this thing you were talking about this Anganwadi workers anthropometric measurement. There has been this thing about this measurement of upper arm circumference, if you are like aware about it. So regarding nutrition thing, so the government has issued a guideline not to rely on the MUAC tapes, upper arm circumference measurement for malnutrition, which was very convenient for the Anganwadi workers. Now they are more focused on the height and weight measurement only. So I was wondering to ask you maybe what exactly it is about, because for them it is convenient. Even after the guideline has been changed, they are using MUAC only.
So
Because
if I have to guess, to be frank, I have not followed that. But what I guess is, I think the way our knowledge and science changes over a period of time, our understanding changes. Two aspects of it here: what is relevant and what is not relevant. If you keep talking to pediatricians, they say, "Okay, we recently the conferences we learned that this method is not so useful." So the changes in our knowledge, okay, from certain experiments, would direct the governments towards certain aspects. But as you rightly said, even in the many areas, I think if I give a correlation that people can easily follow, is TB diagnostics. WHO recommends us to check take the sputum smear. Okay, take the sputum and a simple smear test. So you don't require very expensive instruments. In the rural areas, those instruments are not possible. Even government invests into that. People have to carry it. They may be too heavy, right? Our power may not be there. Electricity may not be there. You cannot even use those equipment. So then what is more likely? Although you are compromising on the science, maybe just utilizing the equipment that can be usable in a given context. Similarly, I think tape use is very easy and very much possible. But we require, I think science may not be helping us to go with certain measurements of the body because they're not useful. Sometimes you're not able to provide proper assessment on that. Then what they are saying, they're going against the requirement and the feasibility of using those equipment so that to support the science. So this all depends on the people who make the judgment. I think we have to find a balance here. One, how much is science supporting the measurement that you are taking, plus how feasible it is in a given circumstance. So most of the times what happens, people who make the judgment, they may go more towards the science but less towards the feasibility, because there may be an ongoing debate on how much of help is this measurements are giving us. Even today, wherever in a very developed country, that even if you go to, because I remember when I've taken my children to hospitals in Canada and here in India, the measurements are not expensive. It's the same height, same head circumference. They're measuring the weight. And there is a standard chart with them. Growth charts we normally talk about, or growth curves we normally talk about. There is a certain percentile that people actually attain. They tell you whether your child falls in 20% or 70%. If they're falling in 20%, maybe your genetic component. Your parents don't have that type of body type. So genetics is giving the idea there. So you actually see whether they're fitting in the average condition or not. But what are the simple measures you are taking? Simple measures are those that are possible in any given circumstance. But always this debate happens. Government may think that this measurement is not useful. They may avoid it. They may promote something else which is not feasible in the given environment. I think this is small corrections do happen. And you look at the overall trend on this. Then what do you notice? And I'm going to give you a brief idea on this. BMI index. Sorry. Excuse me. So BMI index, some conditions I'm going to provide you here, and then usefulness of those measurements that we're going to talk about. It's mostly the variability in the knowledge with time and making judgments based on this. And we may not find right balance, as you rightly said. The people who are here, Anganwadi workers, are semi-trained workers. They're not completely trained to do, they're not doctors. Within the measurements that they can take, we are trying to come up with an idea. Given National Nutrition Mission is gaining so much of attention, so this is now a very, very important component. They're given electronic tools to compute the data so that government can maintain the records regionally. Okay, so many dimensions are happening here with respect to this. I'm going to provide you a brief idea on what type of measurements and indices that we can take. Okay, so also I remember I think 1990s, WHO had conducted a study on this. WHO had provided, there was a conference that happened supported by WHO, where people talked about different measurements that they can take to see the nutritional output. Okay, so we're talking about nutritional anthropology being a specific discipline related to nutrition. So anthropometry focuses on three components. What measurements we take: age, weight, and height. For a given age, what should be the height, what should be the weight. So what anthropologists can do, they can compute the various indices and compare the indices with respect to references. Okay, so assessment of nutritional status, for example. So we take different anthropometric measures. We're talking about where growth is very, very important, plays an important aspect. These measurements are mostly useful for early ages of our life. Like we're talking about newborns and young children. What do we do? In majority of the hospitals, we have these type of features, or these type of equipment. They take the weight, okay? They take the length of the person. So basically they take from the feet, from here, and also exactly to the head. So they measure these length. And they also measure the head circumference, because we talked about this in the growth. Initial 7 to 8 years of age, there's a lot of growth that happens in the head. Head circumference actually helps us to understand those incremental changes. Chest circumferences, how this circumference of the chest is changing over a period of time. This can also provide us knowledge about how fat content is also growing. And plus mid upper arm circumferences you are talking about. Okay, mid upper arm circumferences, if you see here, they're collecting the data on mid upper arm circumference here. Okay, because this provides us the muscle as well as the fat component, because tricep, bicep comes under that, and where muscle growth can be understood here. So height, weight, most common ones are height, weight, and this MUAC or mid upper arm circumference are commonly used. And over that, we may notice that chest circumference is not used. So these type of measures are usually computed. Okay. So for example, what do they tell us? Weight tells us about the body mass. If you're collecting the data on the weight, it tells us about the body mass. We require simple balance for that. Okay, simple weighing scale is required for that, and very sensitive to small changes in nutrition. Like for example, some person is not receiving enough carbohydrates, enough fat. You can clearly see within a month, you can see the difference in their weight. Correct? So very simple calculation, easily done. We need a proper scale for this. And with that, we can understand the body mass, changes in the body mass with weight. What about height? Height is genetically determined. Genetic potential determines our height, but environmental influence can help us understand this. So for example, if a person is not fed well, not enough protein is given, for example. So what happens? Stunting can be easily seen. The person's height is not growing as it is expected. Stunting can be seen. Stunting is a common problem in India. Why? Malnourishment. So with the height measurement like that, so you can clearly know that stunting is the outcome that you are noticing, meaning there is malnourishment happening in that family or in that society. It could be many. The type of crop that they are eating may not have too much of protein content in them. Polished rice may not providing enough of the component and maybe making prone to them towards diabetes, type 2 diabetes, for example. Similarly, the muscle, so mid upper arm circumferences, muscle measurements that we make for mid upper arm circumferences, what do they provide us? They tell us about the muscle as well as the fat, as I mentioned too. Easy to measure because you have to just take the measurement around this part of the body. Okay, quick screening, it is useful, especially for 1 to 5 years of age, whether muscle growth is as expected. So this provides us an idea about the muscle requirements of the body, whether they are growing as expected. There are more fat measurements are also there. There's something called FFT measurements that sometimes the people make. So this is mainly to measure the body fat. Okay, so like I was telling you, certain skin folds that they can take and they can measure the fat content in that skin fold. Either it is behind the body or it is in the near the waist region. If you collect the idea about the body fat there, they can tell how much of fat gaining is happening. And this MUAC would provide us a muscle gain. Height can provide us about the health related to the overall height requirements. Weight can provide us the body mass requirements. So simple measures can give us an average picture about the nutritional aspect of that person. Population level in a given population in a given region, how well they are fed. What is the reason behind that malnourishment, which can be reflected, which is reflected in the changes in their weight, height, and the fat and muscle components. Like that, 4 such measures can be easily taken. These are anthropometry wise, we can take these 4 simple measures. And also what is most commonly used is a BMI index, body mass index. So what is a body mass index? Body mass index is normally calculated by weight over height. Okay, weight over height square normally used here for BMI. So what is the use of this? So normally, let's say a person is 70 kg weight and his height is 1.775 meters, 175 centimeters. So what will be the BMI of that person? 70 kg weight, 1.75 or 175 centimeters. So it would give rise to 22.9. BMI for that person will be 22.9. Correct? This is how you calculate the BMI. We have a reference charts for this. So BMI values for a given age and for given gender, we have standard charts for that. For a healthy person, what should be the BMI for his height and weight? These are calculated. So when you know the ranges of this, as per the WHO, You can classify people based on their BMI into either underweight, normal range, overweight, or obese. Obese also you can classify them into subcategories like class 1, class 2, class 3. So this anthropometry helps us calculating BMI. BMI helps us categorizing people and the risk factors associated with the diseases. Underweight, overweight, both of them are problematic because underweight people tend to have a lower immune system and overweight people are prone to certain diseases like heart related issues, okay, that we talked about. So cardiovascular problems are more common in them. They are more prone to diabetes. So this is what normally happens. So we are getting gaining idea or insight through the BMI index calculations. Below 18.5 is underweight and normal BMI index should be 18.5 to 24.9. So very simple measure, calculate weight and height and you can compute that BMI index for that. Nowadays we have online calculators where you put your weight and height, they will calculate the BMI and give you. This chart is telling us what is normal. 18.5 to 24.9 is normal. Above 25 to 29 is overweight, and above 30 BMI index is obese. And again 30 to 35, 35 to 40 and above 40 tells us the severity of the obesity in those people. So we can make specific changes to the nutritional components and to physical activity based on where we fit. Okay, so these measurements, simple measurements, I told you about 4 measurements for children. BMI for doesn't matter any age. BMI is useful for any age. Those measurements, height, weight, I was telling you, is mostly useful for the early ages of our life. And BMI can be utilized for the later stages of our life. Like the simple measurements can help us what nutritional input is going in and what nutritional corrections need to be made. At times it could be nutrition, at times it could be genetics and your physical activity. So they would get insight into these 3 components. And what do they tell us? If weight to height ratio. So let's say you made the measurements, anthropometric measurements have been made. So what do you learn from it? Let's say for weight for height is decreased. For a given, okay, height, weight has decreased. What does it indicate? It is indicating wasting, malnourishment. Wasting is happening. Their muscle is lost. Body is eating up the muscle for energy. We talked about this in marasmus, right? They become extremely thin, no proper input of energy sources. So what happens? Wasting. Weight for height decrease indicates wasting, indicating malnourishment. Similarly, height for age. There is no proper growth in height for the given age. So the person is actually supposed to taller than that, but the height is decreased for that given age. So this indicates stunting, chronic malnourishment. If weight to height is decreasing, it is wasting. Height to age is decreasing, it is stunting. And weight for age, if it is decreasing, it is underweight. Weight for age is increasing, it is overweight. So what is happening? Protein energy malnourishment is happening in them. So they can tell us what exactly is happening. The measurements can reveal what exactly is happening with those people. So wasting, stunting, and underweight can be seen here. So this is what they do. This is what Anganwadi workers need to report. Take the weight, take the height, okay, and age data. So tell whether they are at the normal chart, normal range or not. If not, wasting is happening or stunting is happening, or they are losing weight or gaining weight. This can be given to especially rural areas where people don't have too much of knowledge about this. And we are prone to more and more diseases because of long-term negligence. And that eventually adds more burden to the government. So that is why these type of programs are very important in India.
So there is something called Z value, sir. I am not aware like if it is mentioned here, sir, which is like for severely accused malnourishment versus moderately accused malnourishment versus underweight. So when that Z value is less than 2, it is a same case like severely acute malnourishment.
Correct. So yes, I don't know specifically, but I think that logically, if you see it, you can categorize how severe is the problem. So immediate attention is required or more long-term care is required. That can be defined based on the severity of the problem. I've not got into that details, but yes, I think it makes sense that providing the rate of severity is very, very useful. So identify a given society, given area, and see what type of preventive measures are required to correct those problems. Okay, so this is what commonly we notice in government programs in India and any country you go to, Africa or even the developed countries. These are the very common measurements that take. So this provides us an idea about the nutritional intake of those people. Okay, I think this more or less I already mentioned to you. These 4 components I mentioned to you. BMI also I mentioned to you. BMI tells about whether the person fits into what category, underweight or overweight or normal category. Low birth weight is also, as soon as people are born, as I think I was telling you this, 1.5 kg normally considered to be the cutoff for survival. So people who have low birth weight, they are more and more prone to diseases, right? And why do they have such a low birth weight? Maybe because of poor nutrition to the mothers. During the pregnancy period, probably mother had malnourishment. To satisfy that, what do they normally do to compensate for that? They provide extra additional vitamins. Supplements are normally given to them. Otherwise, proper food is very important for them. So mostly poor nutrition. Psychological reasons are also there, and the stressful environment can also cause this problem. But you can see the connection to the poor nutrition and the low birth weight. So proper nourishment to the mother is important. So low birth weight helps us understand this, to figure out we cannot do much, but except we can correct for that afterwards. But we cannot correct once a baby is born. But this provides an idea about as a trend in a given population. And mid-upper arm circumferences we talked about. Okay, so this provides this idea about muscle and the body fat that we talked about. So we take the tape, and I was telling you, they normally place around the middle of the middle upper arm, the center, middle portion of the upper arm, which can provide as a muscle component as well as a fat component. So especially it is useful for identifying children who have higher risk for mortality because of less muscle, less fat. Okay, but how much do we rely? This all change with statistics for a period of time. That is why government may go on and off with respect to usage of these type of statistics.
So, but it's really good for initial screening, like you said, sir, because there is this red, green, and yellow thing on this MUSC tape, which just clearly screens the.
So, but easily you can easily filter out where they are.
Yes.
You can easily filter out what is the specific issue with them. This is preliminary, right? There is no invasive method is involved in this. Simple calculation like that can help them to prevent it further, prevent such a change further. I don't think we would normally realize this otherwise. Okay, so like that in nutritional anthropometry, such studies are done. I've given you specific idea about what measures and what do they reveal. Put them into the context as Nikhil is talking about, into the idea of how this is useful in making proper measurements in a developing country like India. Okay, I'm going to give you a case study on this, WHO case study related to that. Okay, so but so far I think we understood the importance of anthropometry, nutritional anthropology, right? So we can give us through simple measures, it can give us the nutritional status of a given individual, given child. Okay, it can give us simple idea about, through simple measurements, it can tell the nutritional status of the child. And it can distinguish between what is happening. Is it stunting or wasting? What is happening in them? Right? Is there a problem in their height, or is there a problem in their body weight and the muscle component? So thereby the malnourishment components can be checked. Either people are underweight or they're obese. So you can see what problem is happening with them and monitor the changes after nutrition intervention. So you keep doing it. You suggest them, okay, I think you require more protein-based food, or you require a little bit of fat. Include these nutrition in your diet. You suggest them and let them come back after a certain period, maybe a month. Remeasure their body dimensions and see if the nutrition really helped. If the specific nutrition that they have suggested, nutritionists have suggested, did it really help? So the measurements would also later help us to understand the importance and the use of such change in the diet. So to assess whether diet really worked also, they can check this. And in clinical settings, in hospitals, what they can do, identify the patients with these type of diseases, and especially patients with certain abnormalities. So here focus mostly on not specific diseases, but focus on certain deficiencies in their diet. So in clinical setting, for disease sensitivity, they can check. For a normal growth pattern in a given population, Someone like Anganwadi workers or a government hospitals, PHCs, okay, public health centers can make simple measures to help people to identify what problems they are going through and fix those problems. Okay. So what are the, so with these measures, so with nutritional anthropology and anthropology in nutritional aspect, what do you think are advantages of this? Advantages, none of them are expensive, very simple, safe procedures. Inexpensive, portable, carryable, tape, balance, most of the times is sufficient enough. Okay. And little training. We don't need excellently trained people or well-educated people here. Briefly trained Anganwadi workers are enough because of the need. How many people can you train? How much can you pay for them, right? So little training is enough. And most of these methods are precise and accurate enough to tell what's going on. Okay, and we can actually make the records of this. How was the trend in last century? With simple calculations, with simple computation, we can actually have understanding on how trend is changing over a period of time. Okay, so these are all the advantages of this anthropometry in nutritional anthropology. Disadvantages, it cannot provide us very specific small changes in our requirements. Only broad changes can be seen. If the weight is changed by a few kgs, you would realize it. If height is changed by a few centimeters, you would realize it. Small changes cannot be identified. Small specific changes which incrementally cause problem, they are within the error of measurement sometimes. So if let's say your weight is 50, plus or minus 3 kgs, you may not realize the difference of within the small changes that happen. So relatively insensitive in detecting the small disturbances. Okay, so short period of time, small changes cannot be detected. So we need bit more quantifiable changes, more distinct changes. And it will also not tell us exactly what was happening in the body. It would only indicate what could be the factor. Okay, so insensitive to small changes, cannot identify the specific reason. To a certain extent, as we have talked about, muscle problem means protein intake. Some correlations can be made, but cannot specifically tell. Okay, and next one is unable to distinguish the disturbances in growth or body composition induced by nutritional deficiencies. Sometimes what mechanism is causing the disturbance is difficult to be identified. So it will only tell the outcome observation, but some other analysis needs to be done for identifying what's causing it. Sometimes you don't even know why you lose weight. Hormonal problem, any health related, other related health related issues. Sometimes you may not be able to figure out. So anthropometry cannot tell us the reason behind it. It can only tell us a difference in the outcome. That's it, with age. So it is mostly quantifiable nature. It cannot tell or reveal the actual problem of it. Even if it reveals in some cases, which is limited. These are the disadvantages of the anthropometry. I'm going to share a bit of case study on this.
So can this thing be cultural also? Like in certain culture, people are like generally found underweight or something like that.
But cultural aspect, as you were saying, the type of foods that they eat, culturally, what is grown, what are the staple crops in a given area. Okay, and the timing of food, and some religious practices. You are actually like festivals, for example, the amount of the type of food that we eat, the amount of food that goes into sometimes is not considered to be healthy in one region, but considered to be healthy in other region. Like I think, I don't know whether I discussed with you, Kerala eating coconut is more acceptable. If you go to America, this is considered to be the one of the toxic food that we can eat. So culturally, geographically, there are differences in what type of diet is acceptable. Okay. And there are, I think, if you get into the details about festival celebrations, type of food they eat, the type of animals they eat in a given festival, so much of diversity. So regional specific differences are definitely there. But overall, what we are learning here is the growth has to be attained. Doesn't matter what it is. And for a given 5-year-old should have these type of height and weight. And we're talking about range. We're not strictly talking about this height and weight. they should fall within this category. If they're falling below that threshold, then definitely something wrong. And then you look further, probe further into their reasons, factors behind causing those problems. Okay, right. So I think I'll stop this part here. So,
One doubt. So
yeah,
all these dietitian we have, so they don't cover under nutrition anthropology.
you can. That's an application of nutritional anthropology. Dietitians are trained people who understand the requirements. They know specifically what diet component would address what. So those are specialists. We're talking about a simple application of anthropometry. Dietitians also use the same data. How do dietitians know? Dietitians would also use the same data of your BMI index, for example, to help you. But they are specialized in understanding the role of those specific nutrients. Whereas Anganwadi workers we talked about basically are the people who take the measurements. So it doesn't matter. You can mention about dietitians, and current days we are having a more specialized focus on what diet is important for gaining weight or losing weight or specific type of weight. So there's an advancement in this. Our focus is on how anthropometry helped them to figure this out. It doesn't matter. Anganwadi workers or dietitians, you can mention about anything. Okay, this is the same science we're talking about. Okay, I'm going to give you this WHO's, this was a report given by WHO, old report, 1995, how children are more and more prone to malnourishment in many areas. Okay, and WHO came up with the idea of anthropometry, how anthropometry, which is a single most universally applicable, inexpensive, non-invasive method, available to assess the various measurements like size, proportions, composition. So WHO recognizes and realized, and it recommended many countries to utilize the anthropometry in order to record the changes that are happening in the children, especially in the ages where they are more prone to this nutritional problems. Okay, so you can mention briefly, you don't have to get into the details, but they put an expert committee where highlighting the importance of anthropometry in dealing with the malnourishment problems in underdeveloped countries, especially in the ages where they are more sensitive to the growth and nutritional aspects. Okay, so this is an old document. I think you can find more. Let me check if there's any more recent document that you can give. But this is a standard document. I don't think much has changed on this in realizing the importance of anthropometry in nutritional aspect. Okay, right. I think I'm going to stop the class here and let's quickly go through the paper. So let's quickly go through the test 3 part. Okay, so this was on 9.1 and 9.6, right? Human genetics part, applications, and then 9.6 is on the markers that we had the test on. First question was on cytogenetic studies. I think more or less I have not found, I think overall structure wise you're all doing well. I'll tell you, highlight few specific problems that you all had. Cytogenetics, I think you all have talked about bar body, karyotyping, fish, and applications. Only thing I felt was when you discussed about bar body, for example, I think some of you have talked about gender, identifying the gender, for example, identifying the genetic problems, which is all right. But it is not just specific for the females, although you can identify with a female or male. So having no bar body is a male, having one bar body is a female. I think one of you have written it helps in identifying only the females, but that's not the case. It can help us identifying either a male or a female. Male has no bar body, female has one body. And abnormalities, multiple. So maximum number of X, let's say 3 X chromosomes are there. So number of X chromosomes minus 1 would result in the number of bar bodies. If you mention so much, that is enough. So bar body, karyotyping, fish. Some of you have mentioned even sky method, spectral karyotyping also you mentioned. That is all right. And always put into the context of applications. So how is bar body connection is useful? How is karyotyping is useful? I have seen some of you are making mistakes here. So karyotyping, the best use of karyotyping is numerical aberration. Change in number of chromosomes are easily identifiable when you organize the chromosomes in a particular order. Mention that. Mention about numerical abnormality being the one of the key thing. Structural abnormalities can also be identified with advancement of things like sky-like methods. Mention that. So you can say it is mostly useful for identifying numerical aberration, can be useful in identifying structural aberration if the problem is big enough, the changed region is big enough, or with more sensitive methods like sky methods are useful. Less fish. Fish is more specific. You can identify the genetic regions with problems, mutations. You can also identify the regions with deletions and duplications. So these are all right. These three methods, I think you all have written. Nothing. These are the problems I have seen. Otherwise, I have not seen too much of a problem with this question. Next is pedigree. This is where I have seen a little bit of issue in presentation of answer. So what are you doing? The question is pedigree analysis. So what do? You have to define what is pedigree. Pedigree is a family chart with the information related to a specific character. I think you all have defined it really, really well. And then you talk about steps in constructing pedigree. You don't have to define terms. You will not have enough space for defining the terms and symbols. We assume that examiner knows them. Don't describe the symbols. Describe the process instead. Avoid describing the symbols. Okay, so what do? You describe how pedigrees are constructed. A family history is taken. You may be able to mention about the Queen Victoria here if you want. Family history is collected, and then for a given characteristic, starting with the proband. Proband is the person who is seeing the data or information. So proband, you put an arrow mark to that proband and you say, these are his parents. These are his sisters and brothers and their family members. Try to put 2 generations at least, parent generation, after that, next second generation, third generation. Put these generations. I think most of you have written well. I think I've seen that you have shown carriers. You have shown, I think one mistake I've seen that, don't line them. Fill the symbols. If they're affected, fill the symbols. Okay, I think you're using just drawing the lines, completely fill it. That is what is normally recommended for that. Don't draw the lines, but fill the symbol. Okay, and so you show the generations, and what I would expect here is show how pedigree chart is constructed. What is pedigree? How is pedigree chart constructed? Then give an example. Okay, an example, it has to be clear. Let's say here following an example for a pedigree chart of an autosomal dominant disease, or following is a pedigree chart for sex chromosome or X-linked recessive disorder. Example, hemophilia, or autosomal disorder. Example, sickle cell anemia. Mention the example. Then give the chart and write 2 or 3 key points. How this chart helps us identifying the disease. It helps us identifying whether it is a autosomal disease, X-linked disease, or sex chromosomal disease. It tells us whether it's a dominant disease or a recessive disease. How do you know whether it is skipping generations or not, whether there is any gender connection or not? So use those key terms, skipping of generations, okay, gender specific. If it is hemophilia, which is X-linked recessive disorder, you will see that goes from mothers to the sons. Sons are usually affected. More males are affected than females. That is how you know. That is how that pattern can reveal what disease you are looking at. So take an example and write it. This is a 10 marker question, so you don't have to give multiple examples. One example is enough. I think some of you briefly talked about 2. Instead, I prefer you to write about one example with how pedigree is constructed, what outcome that you can come up with that pedigree chart, and mention how this is useful briefly. Okay, so rather than mentioning multiples, if you want, mention multiple, but describe one. So what do you say here? Pedigrees can help us identify the nature or the pattern of the disease spread, pattern of the inheritance of the given disease. Okay, so you talk about the uses, how pedigrees are used. You can tell about sickle cell anemia, hemophilia, how pedigree charts can help counsel in genetic counseling. Also, how pedigree charts are non-invasive methods to simply construct something like this and understand the pattern. And ensure very briefly, because 10 marker, if it is a 15 marker question, I would have asked you to focus more on limitations. I've seen some of you have discussed more about limitations, but keep it simple. You will not have enough time to do it. What is the most important part that you have to discuss here? What is pedigree? How our pedigree charts are made? And give an example of it. And then talk about how they are useful. Limitations, focus less. For 10 marker, you will not have too much of time. Just mention that. So because I've seen that some of you have failed to identify the right points. If you have to choose a more obvious one and the clear ones. What is the limitation? As I explained you, it can tell the pattern. It cannot tell what disease it is. Can pedigree chart tell you what disease it is? It can tell you the inheritance pattern of it, whether it's a dominant, autosomal, recessive, etc. It will tell you. So it cannot give you the exact mechanism or the problem there. So exact cause cannot be revealed. And another problem is, I think, Nikhil, if I'm not wrong, you mentioned this, that we have enough population as an advantage. But the problem with this is lack of record keeping. It's not about population size, it's about how much records they kept. How much do they know about their parents, their grandparents? Did they ever have written anything about it? They might have not. I've seen many families where genetic problem is there, they don't know, they don't track it at all because they don't have knowledge about it. So highlight those issues, but just very brief, maybe a sentence in the end, because you will not have time. Otherwise, your focus should be on these things.
Sir, second point, the steps in constructing pedigree, we have to put it in form of an example. Like I didn't understand this point.
It's up to you. So two ways that you can do. One, so what do you say is, how is pedigree chart constructed? Collecting probe and approaches the person, a genetic counselor or a geneticist. What do? They basically collect the data related to that particular disease in the family. He puts them in the order. So what you can do, you mention this and give example underneath it, or start with the example. In the process of explaining example, show how it is constructed. Doesn't matter. So what I'm seeing here, the process, explain the process of constructing pedigree chart. What is pedigree chart? How is it made? With an example, how is it useful? What are the limitations? Okay, is that clear? Right. If you want, I will show you. I think Nikhil, if I'm not wrong. So this is not needed. So describing this is not needed. You draw this and just explain it. Okay. And also filled symbols is what I was looking for. And one problem I found in yours is availability of knowledge among ancestors. Okay. So instead I would say lack of data. Rather than saying phrasing it as lack of knowledge, I would say there's not enough data. Or you put both. Understanding of pedigrees use is not there, and data is also not available. That is the biggest problem with pedigrees. No data. That is why Queen Victoria became the example, because they keep data of the royal families. And you mentioned long human lifespan causing the difficulty in analysis. So choose the right terms. So generation time, long generation time is causing the problem. So choice of terms is very useful. Examiner would get the idea better. This would come with the practice. I just wanted to highlight the problems. Okay. So you just rephrase them so that it is your idea is clear to the exam. Okay, right. Next question. HLA polymorphism applications, I think more or less you've all written well. What is HLA? It's a marker. So genetic marker. So why genetic marker? Because it has, you have also nicely drawn, simple diagrams are drawn. We don't need specific details, just simply drawn polygenic nature, polymorphic nature. I like that component. So you explained both polygenic, polymorphic nature. As it is polymorphic, there's enough room for, enough scope for studying the populations. Explain that in the applications. So applications have to be clear. What, first of all, HLA or MHC is present on all our cells, MHC1. So some of them are present on only on antigen presenting cells. So it is playing an important role in recognizing self and non-self. So what is our body's component? What is foreign component? So your immune system functions based on MHC or HLA. Talk about that first. Then organ transplant. You have explained it nicely. Proper match is required. So with proper compatibility, organ transplantation can be more successful. Otherwise, it will be rejected. Talk about it. Paternal disputes. You talk briefly about it and mention it can only do so much, because paternal disputes cannot be with precision. It cannot solve it. Sorry, HLA, right? So we can definitely solve the paternal disputes with enough precision. So mention, given the polymorphism, those polymorphic components can be identified through proper probes. So definitely it is useful in paternal disputes and population-wide analysis. So this I have not seen much a problem in your answers. I think you more or less have written well. I'll show you one of yours. Sunil, one of yours. Sunil, definitely you improved in terms of content this time. You have performed better in the last time. because the content has improved. So you made the same mistake in the pedigree. No need of mentioning this. In the class to teach it, I have to go through that order, but you have to retune it, reorder the information. But in this type of chart example is good. Applications, clearly you're mentioning applications to the point. That is good. Okay, yes, I think the problem with your first part of HLE is all vertebrates, there is genetic region that has certain genes which code for some protein responsible for deciding whether a graft can be accepted or not. Don't use long sentences. Sentences have to be crisp and short. 4 lines of sentence would not make sense to the examiner. Always use short sentences. So what do I write here? In all vertebrates, there are genetic regions which are different, which show polymorphic nature. Okay, so you are trying to define here genetic marker. So polymorphic, genetic polymorphism, genetic marker you are linking. You don't need to stretch so much for that. Okay, to improve the clarity, focus on the keywords. Polymorphism means same character or a related gene is present in multiple forms, A, B, O blood groups, multiple blood groups. Explain it with simple example like that. Simple, clear definition is required to begin with, because that gives you an impression to the examiner how well you are going to write. Okay, so simple statements are better. Okay, otherwise flowchart use is great. So you talked briefly about class 1, class 2. For a 10 marker, you may not have too much of scope here, but yes, mentioning class 1, class 2 is briefly is sufficient here. And you talked about polymorphic nature, polygenetic, polymorphic, this much is enough. I think if you say A, B, C locations, DP, DQ, DR is sufficient. Okay, right, applications, immune responses you mentioned, organ transplantation you mentioned, anthropological studies you mentioned. Okay, so because of definition, I took a half mark from this, otherwise you would have got 5.5 marks. Okay. HLA, HB variation, hemoglobin, I think you all briefly gave introduction, hemoglobin, polymers you mentioned about, function, this is very clear. Age variation, gender variation, population, organize information like that. That also you more or less done. Age variation. Age wise, I don't know, I mentioned about 4 of them, A1, A2, and E, epsilon, F. Okay, so mentioned about them, embryonic, fetal stage, adult stage, hemoglobin varieties you mentioned. I think with flowcharts you mentioned well. Gender variation, okay, gender variation, quantity of hemoglobin which you gave. Some of you have given full chart, you don't have to give full charts. Talk about females, males, children, that is enough. And the population level variation, hemoglobin variation, or I think you have nicely pointed out at HBS, and specific varieties, especially for hemophilia, not hemophilia, especially for the sickle cell anemia condition. You mentioned those variants. Okay, I'll show you one of your answer. Sunil, if I give you. Yeah, age, gender, population variation. You defined hemophilia. Chains you briefly mentioned. You can draw a simple diagram to this. If I'm not wrong, I actually think they've drawn diagrams for this. Use that approach. Hemoglobin. Simple diagram like this. And variation in population, A1, A2, and F, and HBE also you can mention, right? So this organization flow charts, I think you did A1, A2, that is all right. Okay, fetal variation that you have mentioned, and the gender related variations you have mentioned. Briefly mentioned about hemoglobin compared to the mean value of this, compared to the men and females, how it changes. I think I would expect here a little bit of numbers on it. Like if you see Nikhil and Yash, I think they both have mentioned that 14 plus or minus 2, 12 plus or minus 2 children. These 3 categories are sufficient. I think Yash has also done the same thing, or Yash I think went a little further. We discussed a bit more on this.
I planned to, but I couldn't recollect.
That's all. Normal. In general, about 14 in men, about 12 or less in women.
I checked from your notes, my numbers were also not very correct.
But that's all right. Approximately is fine. So we don't have to be too precise on that. But you could show that there are three categories: women, men, children. That is all. Children tend to have more. I think Yash, you have probably provided from exactly what I've shown in the class: 17, 12, and men around 16 plus or minus, meaning 14, 15, 14 to 17 or 18 you see it. In a way, 15, 16 is enough. Women show that about 12 or below. Okay, so this even if you go wrong by one part of it, I don't think it matters too much because there is a range to it. So which is all right. Okay, mention so much, and then population. So these three, if you talk about gender, age, population variation, is sufficient. And next, thrifty genotype. Straightforward, I think more or less you all did it well. What is thrifty genotype? If you go to Nikhil, you've written it crisply. Your answer structure is very good. You're adding enough components, but I feel like some answers you are falling short of information. They look too short. I've mentioned it in some cases, like I don't know which one specifically I've mentioned. I think nature nurture, for example. You have not given a case study. Okay, you're falling short of information, but otherwise crispness is good. Terminology, choice of terminology is good. Your diagrams are also good. Flowcharts and diagrams are also good. Just needs a bit of more content. And I think also you didn't answer all the questions, correct? So trying to answer all of them would also helpful you. So otherwise, Zunil definitely improved from the last time. Content is more. Now you're writing more specifically. So you performed well this time. And Ash, I think you also missed some questions, right? Otherwise, you also usually have crispness in your answers. You attempted even to draw images of regions. Okay, so if it is possible, do it, or briefly only highlight few regions. You don't have to draw everything. Highlight few regions, which you have done here. Certain blood groups, I think you have specifically mentioned. Patterns in Africa that you have mentioned. Asia that you have mentioned, which is all right. Okay, right. What is 50 genotype? I think straightforward. Give the factual data for this. I think one of you have not given the factual data. The James Neal in 1960s approximately have mentioned this. And otherwise, your concept is clear. Okay, you explained it well. No problems with it. 50 genotype, key points in 50 genotype. All of you have written it well. Written it before, yes. 50 genotype. Yeah, I think Nikhil mentioned who proposed it. There's some theories we're talking about it. Particular individual might have proposed it. So mentioned about them and describe the process. And the problems with the hypothesis was not very clear to me. You said type 2 diabetes is genetic, has not been proved. The genetic potential of the type 2 diabetes is proven. Okay, we don't know the exact genes, but we know it is genetic elements are there. These are called genetically influenced diseases. Okay, so this statement is not clear. How are you connecting it to the hypothesis is not clear. Okay, otherwise other 2 points are fine. So wherever I'm unclear about what you're writing, I underline it with red. Okay, so better phrasing is important there. Clarity is important. Right. So otherwise no issues with this. And question 2, what is the genetic markers and what are their usefulness? Why are blood groups considered as good genetic markers? Okay, enough scope. They're already given subheadings to you in this. What are genetic markers? First, define genetic markers. What is their usefulness? Second point should be applications. Use the same terms. If they use the word usefulness, give the subheading as usefulness. So match in the tone of the question. And then uses and applications. So you probably would have given already enough examples and applications here. Then you have to justify why blood groups are considered as genetic markers. So third component of the answer should be genetic blood groups, what type of polymorphism they show, and what is good about them. I think couple of 3 points that you have to mention here, which I think you have highlighted here. Blood groups as good genetic markers. So I think Nikhil, you didn't attempt the answer, right? So one of you, yeah. Genetic markers, yes. So genetic markers, definition, identifiable genetic sequence. So reference point this is a reference point. Okay, types of them. From the syllabus itself, you can give the types of them. HLA, serum proteins, gamma globulins, something like this is sufficient. Usefulness. So one thing you said, identify a gene. We cannot identify a gene, we can identify approximate through the reference point, we can identify where is it present approximate reference. Through reference point, you can identify the approximate location. Nature of the gene cannot be identified. Genetic marker may not give us nature of the gene. Okay, right. DNA segment you mentioned, genetic markers, ABO blood groups, HLA system, haptoglobin. Haptoglobin, you mentioned that important role in preventing kidney damage. That is the work of haptoglobin. But you have to describe in the context of genetic marker what is its use. Haptoglobin may be useful in preventing kidney damage, but how is it useful in marker as a marker? There is enough polymorphism related to haptoglobin that you can study. Okay, its work is preventing this kidney damage. Okay, and blood groups, you mentioned different types of blood groups and frequent, so more standard blood groups present in all populations, so becomes a very good genetic marker. Okay, and also you see some correlation between the disease and the ethnic groups. So because of this diversity of information available to us and connection that we see here, and they don't change with age, they don't change. Their frequency, their quantity, none of them change. So mention those key points. Enough data and no change with the age factor that you can specifically see here, and ethnic differences can be identified. If you want towards the end, because we don't know concrete ideas on this, disease relevance, if you want, briefly mention this as a fourth. So like that, justify why blood groups are important. And if you want, they say that paternity disputes can be solved to some extent. They can only rule out who cannot be the father. They cannot identify whether he can be his father or not. They can say he cannot be biological father with his blood group combinations from the mother and father. You don't have to explain in detail. I think one of you attempted to do that. I think Sunil, if I'm not wrong. Don't have to draw all the tables here because you may not have time for that. So where is that? Yeah. You give one or two examples, that is enough. If you can manage with time, great. This is great information. But if you cannot manage, give one example. In this particular condition, let's say parents are so and so, child of this is not possible. So with this combination, this father cannot be possible. Like that you can mention. You don't have to draw all the charts, maybe one or two like this from this and show it with an example if it's used. Okay? Very simple method. Don't require HLA polymorphic analysis, requires more time and money. Blood group, very simple, maybe 200 rupees, 300 rupees test. That's it. So you can mention that. Okay, right. So blood groups, mention about these components. And what do you understand by biochemical genetics? So how should be the answer here? Explain with examples. So define what is biochemical genetics, discuss the scope of biochemical genetics. Within them, inborn errors of metabolism, genetic diseases, hemoglobinopathies are the three things you can mention. Either you talk about them as examples or you mention, first you talk about scope, DNA, RNA, proteins, enzymes, you mention about them. Then finally you can talk about the inborn errors of metabolism. Traditionally is the most known example for biochemical genetics. Talk about, Gerard and Archibald, for example, the phenylketonuria, alkaptonuria examples, talk about them, which you have talked already, mentioned about. So hemoglobinopathies you can mention. And one thing I've seen as a problem here, you went on focusing more on the methods. Look at the question. If they're asking about biochemical methods, in that direction, it is all right. But they're asking, what is biochemical genetics? Explained with example. So focus on inborn errors of metabolism, genetic disease like sickle cell anemia, hemoglobinopathies is all right. With respect to that, mention the method. These methods are useful, but don't focus too much on the methods. Question is not demanding you to talk more about the methods. I think one of you, just two of you have written that. So biochemical genetics, like Sunil's your answer, they defined it what it is and talked about scope, gene expression, enzymes, metabolic pathways, etc. And you talked about these two examples, alkaptonuria, and you talked about phenylketonuria and hemoglobinopathy. This is all right. You went on connecting to immunological methods, but you gave immunological methods and wrote. You have to provide connection. Why you took immunological methods as example for biochemical methods? Because those component cells are also nothing but biochemicals. So you give that connection. Don't give the subheading as if you are writing it for immunological methods. You say molecules like B cells, T cells, and their variations can be used in identifying so and so. ELISA test, same thing. You're focusing on a marker called a protein, antigen or antibody. So in that sense, ELISA can be related here. But I don't expect too much of answer for the second part. This is not needed at all. Brief information is enough. Otherwise, I wanted to expand more on hemoglobinopathies, phenylketonuria, and alkaptonuria. Mention simple biochemical tests or protein polymorphism studies are useful. Electrophoresis like methods are useful. Don't try to explain the details about the methods and don't need to add all these components of immunological methods and antibodies. Because hemoglobinopathies, phenylketonuria, alkaptonuria sufficient enough. Just expand on those three. Okay, who else have written this? Yash, have you written the answer for this? Yeah. So biochemical genetics is an area that deals with study of biochemicals. Study of what aspect of biochemicals is important. The corresponding genetic elements is important. You're looking in the context of genetics. What genes are responsible for those elements you are looking into? That is must. Okay, so scope is good. This type of chart is very useful. Sunil, you can adapt to these type of charts. Sunil, you can actually use combination of statements and these charts. Okay, Archibald Gerald, enzymes, phenylketonuria. This organization is very good. Yes. And the biochemical methods you went on discussing about. Instead, I would like you to talk about the methods as part of these three categories, rather than separately talking about the biochemical methods. So you reorganize your information. No need for going for a subheading like biochemical methods. Put electrophoresis as what Sunil did. Put under the diseases like hemoglobinopathies. Give an example of method called electrophoresis.